Hello everyone, I'm Leonardo Boria, and I'm happy to present to you Earthview, the new podcast talking about Earth. Today we're going to look at the hydrosphere. Let's begin. Hello, Dr. Boria. I'm honored by your presence, and I would like to ask you some questions about the hydrosphere.
Sure, go on, but I don't have much time. I have an important meeting in a few minutes.
First of all, what is the hydrosphere?
The hydrosphere is a part of the Earth, and it is composed of all of the water present on our planet, both on the surface and below. It has a lot of importance for the maintenance of the ecosystem. In fact, without it, life wouldn't exist. I think it is very particular because unlike other spheres of the Earth, the hydrosphere is spread underground, on the ground, and in the atmosphere.
What is the composition of the hydrosphere?
So, the hydrosphere is obviously composed of water. In detail, it is composed of 96.7% of water, which resides in the sea and ocean, and 3.3% is fresh water. That 3.3% is 68% in glaciers and ice pockets, 30% in water tables, 0.02% in lakes and rivers, and 0.001% in the atmosphere. This means that most of the water on our planet is not drinkable, as seawater is salty, and if the salt is not filtered out, the water can't be drink.
How does the temperature in the sea work?
Basically, the deeper you go in the ocean, the colder it gets, because solar rays can't reach that far. In fact, solar rays can only reach up to 10 meters deep, which is very little considering that the deepest point in the Atlantic Ocean is at 8,605 meters under the sea. In some depths, the water temperature can get even lower than 0 degrees Celsius.
Why does it not freeze? How is that possible?
Basically, when water has salt in it, it has a lower freezing point. The more salt, the lower the freezing point. Anyway, as I was telling you, in the ocean there is a zone of transition from the waters the sun hits and the ones which don't get hit. This zone is called the thermocline. This is the zone most animals will not venture beyond due to the cold found deeper and due to the absence of vegetation which many animals eat.
How do the sea currents work and why are they significant?
Sea currents are slow and regular movements of big amounts of water. These water differ from the surrounding ones thanks to their salinity, the amount of salt in the water, their temperature, their density, and sometimes also color. These currents can move water horizontally, which divides them in superficial or deep currents, or vertically, which divides them in ascendant or descendant currents. Superficial currents are often created by the difference of temperature because deeper the water gets colder. These currents are hot waters from the equator which move to the north, give away their heat, and return to the equator where they give away their cold and heat up again. This is very important to keep temperature stable and balanced. Currents are influenced by constant winds, Earth's rotation, and obstacles such as continents. Furthermore, currents have a big impact in the places they pass through. They affect the temperature, the humidity of the air, and how clear the sky is.
When is water dangerous?
Water is dangerous when events such as tsunamis or seaquake happen. Usually it starts with an earthquake with its epicenter in the sea, with a landslide underwater or at the coast, or with a volcanic eruption. It has a big difference from wind-caused waves, because seaquakes are an actual movement of water, a whole column of it, which in deep water appears as a small wave moving very fast. But as it gets closer to the beach or coast, the water is much more shallow. At this point, the wave gets much taller, even more than 20 meters, causing big damages. These events may be preceded by water appearing to be pulled back before the wave, but this depends on how the coast is. Obviously, these events are very dangerous and often cause lots of death.
That's all. Thank you very much.